Hi, this is John Tour. Thank you for joining us for today's webcast, Xsigo, the Data Center Fabric for the Cloud. In this 30-minute overview, I'll provide you with a quick look at what a data center fabric is, the problems it solves, and what it's made up of. The data center fabric is really meant to solve the most compelling IT challenges in today's data center. And really you can think of the challenges in four different ways. One is the challenge of consolidation. Everyone's looking to bring together resources, reducing either the number of devices in the data center or even the number of data centers overall. That's being met at the same time with expanded services. You're being looked to bring more things into the data centers, bring desktops into the data centers, bring management of multiple devices into the data center. With over 7 billion devices expected to be deployed by year 2020, the processing load, the workload, the content for all of those devices is going to have to reside in the data centers. The way we're meeting these challenges is with virtualization. Over 50% of workloads are now virtualized, which does help to increase server utilization, but creates a lot more challenges for how you connect those servers to networks and storage. And finally, along with all that flexibility you're being asked to deliver, the requirements for security are actually increasing. There's more different kinds of information being held in data centers and being held in data centers that are publicly accessed. So you have to be very concerned about how that data is being protected and whether or not it's compliant with the numerous different regulations on the books and soon to be put on the books. Data center fabrics address these challenges in a number of different ways. The challenge of convergence is met with any-to-any connectivity. The idea of a fabric is that you can connect anything to anything in the data center or even between data centers to help convergence become a manageable activity. Virtualization growth is met with a fully virtualized infrastructure. The fabric is a virtualized infrastructure to match the flexibility and high utilization of the servers themselves. A fabric is inherently simple and more scalable than a traditional IT infrastructure. This makes it easy to expand services to meet the need for all these new devices, to meet the need for virtualized desktops, to meet the need to virtualize mission-critical applications. And then finally, from a security standpoint, a fabric provides network isolation. So the idea of being able to create isolated networks on demand and have them act as physically separate units, even though they're contained within the same physical infrastructure, allows you to meet security requirements while at the same time meeting the flexibility and utilization requirements of a fully virtualized data center. A fabric, can be thought of in a couple different ways, and certainly the idea of the image of a cloth with weaves, fibers going different directions, all interconnected, is a useful analogy because that's exactly what a fabric is doing. It's providing you a way of interconnecting many different things simultaneously over a single infrastructure. But it's not a single thing. A fabric itself is not a single device or single box. In fact, it's an architecture. So you can think of it as a method or style of construction. It's a way of building a data center that's enabled by a new class of devices, such as Xsigo. At Xsigo, we think of a fabric really as being two things. One, it's a converged infrastructure. You want to be able to bring together Ethernet traffic of all types, 1 gigabit, 10 gigabit, 40 gigabit, over a single infrastructure. And you want to be able to combine fiber channel on that same infrastructure. If you want to be able to simplify your data center, you need to bring everything together into one infrastructure. It's not sufficient to have one for Ethernet and one for fiber channel. And then over that single infrastructure, you need to virtualize the connectivity. You have to be able to create isolated connections, just like the physical connections you have now, but be able to do it from any server to any network, to any storage, or to any other server, and be able to do it in real time. So once you have these two things, you converge down to a single physical infrastructure, and you've given yourself the ability to virtualize connections. So you haven't sacrificed any isolation, you haven't sacrificed bandwidth control, you haven't sacrificed anything you get with today's physical infrastructure. Once you have these two things, then we believe you have a fabric. So what that fabric does for you is give you a pool of shared elastic resources. once I can connect anything to anything, I can now take a group of servers and I can say, you're my web servers today, and these are my database servers today, or these servers are serving this customer, or these servers are serving that project. And when things change, all those assets can be reallocated. So it's a pool of resources that I can dynamically assign. And what that lets me do is configure services and deliver them on demand. So if I have a new requirement come in, say I've got a work group that now needs VDI, I can easily reconfigure my resources to deliver that service quickly without having to go in and rewire my data center. And then finally, we believe there's an element of vendor flexibility as well. And the reason for this is that most data centers tend to be heterogeneous. You tend to have multiple vendors in a data center. If I don't have the ability to bring together all of those resources under one roof, under one management model, within one fabric, I haven't consolidated my data center. If I've got one pool of assets from vendor A and another pool of assets from vendor B, that's not consolidation. So if I want to consolidate, I have to be able to bring together all vendors, all types of servers, all types of storage, all types of networks within a single fabric environment. Then I've converged, but to do that I have to have multi-vendor flexibility. One thing's for certain, and that is that the traditional infrastructure does not meet any of those requirements. It's complex and flexible and has built-in bottlenecks. The complexity is in layers. You have aggregation layers, you have different types of devices, you have appliances that have specific functions, all of these wired together in ways that are very, very hard to change once they've been put in place. That inflexibility is what prevents you from dynamically allocating resources. You cannot reconfigure things on the fly. Matter of fact, in many cases, you can't really reconfigure things ever. Once a server is wired in for a specific function, it's pretty certain it's going to have that function through most of its useful life. And then finally, the way that networks are designed with aggregation layers limits performance. And it does this in a couple of ways. One is obviously as traffic moves through the layers, you're adding latency, you're adding potential bottlenecks in the links that hold those layers together. It's also limiting performance in that once a server is connected with a specific amount of bandwidth to a specific network, that usually doesn't change. So I've built in a certain amount of performance I can get from that server on day one. And if my requirements change, it's going to be very difficult for me to change the delivery of bandwidth to that server. So I really can't respond to new performance requirements. So the traditional infrastructure introduces a lot of things that really limit your ability to do all the things we talked about in the previous slide. The fabric, on the other hand, completely changes that, because it gives you a simple, agile, and fast way of connecting and managing the data center. It's simple because it is a converged infrastructure. You're bringing together everything into one set of interconnects that combine Ethernet and fiber channel into one physical infrastructure. And it's agile because the connections within that infrastructure are all defined in software. So you're not losing any of your ability to create isolated connections. You're simply creating those connections entirely in software rather than doing it with physical wires. And finally, it's fast because the fabric is designed with a very high speed infrastructure. You build it with the fastest possible transport. And secondly, it's inherently efficient because it's a single layer of topology. You're not routing data through multiple aggregation layers and up and down complex stacks. So let's take a close-up look and see exactly what this fabric is. This is a before picture of a data center without a fabric, very typical type of deployment with Ethernet cards and fiber channel cards and different servers connected up to switches. And of course, this is actually a very, very simple deployment because I've only shown one layer of switches in here. So it's actually kind of idealized, but nonetheless, you can see the challenges. Everything is hardwired. If you need to connect anything new together, it becomes a configuration problem of going to each server individually and making those connections happen. What a fabric does is it converges the infrastructure. So you're converging all of the connections from the servers, all the fiber channel and Ethernet connections, down to one wire. It's actually two wires for redundancy, but both wires have exactly the same function, and they actually work active-active, so they can be used in parallel. The single wire connects the server to a device in the fabric, which we call a fabric director. So the data center fabric can consist of multiple fabric directors, anywhere from 1 to 8 fabric directors within the data center fabric. Each server is connected into one of those or two of those fabric directors by a single card in the server. That physical card in the server is an off-the-shelf item available from all major server manufacturers. What the hypervisor and operating system see inside the server are virtual NICs and virtual HBAs. So they're not actually seeing that physical card. What they're seeing is that card being virtualized into multiple resources. Just as you would virtualize a processor to create multiple virtual machines, you're taking that single physical card and virtualizing it to create multiple virtual NICs for Ethernet connections and multiple virtual HBAs for fiber channel connections. Each of those acts as a standalone connection, connecting that server up to a different network or different storage asset. Those connections and the virtual cards themselves are all created in software. So with software, you can connect from any server to any network and any storage in real time, and in fact do it without any kind of reboots. The infrastructure is very fast. To the Fabric Director, you can support up to 40 gigabits per connection times 2, which means you got up to 80 gigabits from the Fabric Director out to each server. So 2 cables going out to that server in a wire-once environment. Once you create that virtual connection, you can actually set on it QoS controls. So just as you would select, a 10 gigabit physical infrastructure, you can create a virtual NIC and assign it a 10 gigabit QoS. So you have exactly the same kind of bandwidth control as you would have in a physical environment, but now everything is software defined. This is all completely open, and it's not dependent on any kind of specific operating system or hypervisor. So the beauty of this is you can combine all the servers, virtualized and bare metal, into a single management environment. And you can combine different types of hypervisors within a single management environment. So you can run VMware, Hyper-V, Oracle Virtual Machine, all under a single management environment for your connectivity. The beauty of this is that it's extremely agile. Not only can you create new virtual resources on live servers without a reboot, you can also migrate those resources from server to server. So if a server is being taken down for maintenance or it's being updated to a new server, you can migrate all of the virtual resources from one server to another, and all of the assets go with that. The MAC address, the worldwide name, all the things typically associated with hardware, specific cards, will go with that virtual resource. So now I can move all of the connectivity from one server to another, and I don't have to remap anything in my network. I don't have to reassign any of my LUN masking. My entire SAN and Ethernet configurations remain the same because the MAC address and worldwide name have moved with those cards. When I want to create new networks in my data center, say I've got a requirement, for example, to handle payment card information, I can create a new network in my data center and instantly make that network accessible to the servers that need it simply by creating new resources on those servers. So I've vastly simplified the process of adding new capabilities in my data center because I don't have to touch the server. The most complex, the most numerous connection in my data center is now wire once. So for the entire 5-year life of the server, I never have to touch it. Now this reduces complexity in numerous ways. We've talked about the agility. From a physical standpoint, it's 70% less complex. You're reducing layers of infrastructure. You're eliminating many, many connections to each server. You're also giving yourself the ability to bring devices into the server environment that would otherwise be standalone, such as firewalls. If you want to run a virtualized firewall within your server environment, you can now bring that into a server, run it as a virtual machine, and you can create virtual networks that will connect that firewall to other assets. And because those connections remain completely isolated, I can now operate that firewall within a single physical infrastructure exactly as it operated in my more complex traditional infrastructure, without relying on VLANs to provide that isolation. So I've given myself numerous opportunities to make my data center both simpler and more agile. And the difference is dramatic. The before and after, just from a physical, the obvious reduction in complexity standpoint, getting rid of 70% of the connectivity has a dramatic impact. If you compare these two stacks here with the traditional infrastructure on the left and the Xsigo infrastructure on the right, the Xsigo infrastructure actually has more bandwidth and more connections per server, but you can see with substantially less complexity. And this has a big impact not only in terms of cost, it's also system availability. A much simpler infrastructure is much easier to debug and is going to have a lot fewer things to go wrong. So I talked about the 3 attributes: simple, agile, fast. Let me just expand on those a little bit here. From a simple standpoint, the converged infrastructure means fewer switches, cards, and cables. That means I have a simpler physical infrastructure. It also means I can now use smaller servers. I can take a 1U or even half U server and get whatever I/O resources in that server I need from both Ethernet and fiber channel standpoint. Same thing applies to blades. I can get all the connections I need and all the bandwidth I need to any blade without having to worry about how many mezzanine cards can I accommodate and what kind of switch modules have I got in my chassis. None of that matters anymore. It's just wire in the Xsigo connection into that blade, and you've now got all the bandwidth you can use, and you've got all the connections you need. It's a flat architecture. It's a simple single layer of hardware between the core network and the server. So that simpler topology means fewer tiers, less cost, more performance. And everything is software defined. So now I can define all those connections in software, which means I can eliminate the complexity of having to go in and physically rewire things in the data center. That's huge on agility. The fact that I can now manage things without a reboot. If I've got a server that's running 100 virtual machines and I need to add a connection to that server, I don't have to bring it down. I can go ahead and bring those, add that connection in, go into VMware and configure that connection for use by my virtual machines, all without having to reboot that server. This allows me to deploy new services much faster than I could otherwise. I've got bandwidth and connectivity both on demand. So when I need more bandwidth for new services or I need more connections, they're available to me. And it's any to any. The ability to connect from any server to anything else in the data center is a huge asset in terms of being able to make better use of those resources and make better use of the network itself. You're no longer going to have a bunch of connections lying dormant. The utilization on networks is no better than the utilization on servers used to be. It's probably on the order of 5%. So with this, you've got a simple, very well utilized network environment where I can connect anything to anything. And you're not sacrificing any performance of this. I mentioned that to the Fabric Director you can connect up to 40 gigabits per connection. Going from server to server, entirely within the fabric, I can actually get up to 56 gig on each connection. So I've got a lot of bandwidth, both from the server-to-server interconnect and also from servers to networks and storage. So you think about, where does server-to-server matter? Well, think about vMotion. Think about backup, where you're talking from an application server to a backup server. That server-to-server throughput, where I can get up to 56 gig per connection, is going to run dramatically faster in the Xsigo environment, which speeds up management tasks that are traditionally very time-consuming. I've also got granular quality of service on both network and storage. Xsigo is the only vendor that provides bandwidth control on both Ethernet connections and fiber channel connections within a single virtualized environment. And it's done over a fabric that provides you with very, very low latency, microsecond latency. It's 1/3 the latency of gigabit Ethernet. So everything's going to happen faster. Applications are going to run faster. You can run more applications per server, increased VM density, all of which helps you to run a faster, more agile, more cost-effective data center. And all of this is open. The cards that go in the servers are conventional cards. The ports that are being presented to the core networking, the fiber channel ports on the Xsigo device, the Ethernet ports, are all standard connections. So everything looks very, very traditional. What we're presenting inside the server looks like traditional NICs and traditional HBAs. So what that means is you can leverage your existing investment. There's no swap out required in terms of your core networking. You can leverage your existing servers and maintain the flexibility to buy whatever servers you want. So this gives you the ability to choose, the storage of your choice, the network of your choice, reuse what you have, and maintain that sourcing flexibility. A question that often comes up is, if you're converging to a single fabric, how do I maintain security? I need isolation. In many cases, virtual LANs are not sufficient to provide the kind of isolation I need for some of my applications. And Xsigo actually does create isolated connections within a single fabric, because what we're presenting to the outside world can be brought out on multiple isolated ports. So what that means is we can create isolated networks within the fabric which have no visibility to each other, bring those fabrics out on physically separate ports, so when they're presented to the outside world, they remain physically isolated, and thereby create isolated layer 2 networks on demand. So we're creating connections in software that are remaining completely isolated and giving the ability to maintain that isolation right to the outside world with physically separate ports. So what that does is says now I can support security and compliance requirements. It's been audited by security experts and found to be an isolated network environment over a single fabric. So think about what that can do for you in terms of creating isolated data centers within your fabric. So say, for example, a service provider that wants to create virtual private data centers for customers. I can now go into a single physical environment, create a group of servers, a group of virtual machines, connect those things together with an isolated layer 2 network, bring that out to a separate port, and now that customer has a complete data center standalone within a single fabric that's shared by other customers. This multi-tenancy delivery is the key to creating the private cloud or even public cloud enterprise data center. And all of this is converged. It's fiber channel and Ethernet over a single, lossless, highly reliable fabric. So it's very compatible with the lossless requirements of fiber channel. You cannot reorder packets, you cannot drop any information, and you have to do everything at full line rate. That's exactly what Xsigo delivers. A 40 gig connection to the fabric director means that we can run 8 gig fiber channel, 10 gig Ethernet over that single connection and ensure full line rate for both. Ensure that we're not dropping any packets or reordering any information. And in fact, 90% of Xsigo customers today use fiber channel and Ethernet together within a single converged fabric successfully, and in every case they find that they get as good or better performance with fiber channel over the Xsigo environment as they got with their standard fiber channel gear. And in fact, it is standard fiber channel silicon. What we're presenting to the outside world is standard QLogic silicon. So it looks very familiar to your core switching devices. And inside the server, we're presenting virtual HBAs, which also look very familiar to your software. So both ends of the pipe look familiar. The pipe itself is extremely fast and lossless. So it delivers a great fiber channel connection that's very high speed and looks very traditional. So where do you use these things? Well, because this is an open solution, running on both virtualized and bare metal servers, it has a lot of different applications. Certainly virtualization would be the key, because as you virtualize your servers, you really run into the connectivity challenges of more connections, more bandwidth. Same thing for virtualized desktops. VDI creates a number of unique challenges, and when you're being expected to deliver a user experience which is the same or better compared to a conventional desktop, and being expected to do this at a low cost versus a conventional desktop, it can be a real challenge. So how do you meet that challenge and do it within an infrastructure which is as complex as a data center usually is? Well, you simplify, you consolidate, deliver more bandwidth to the server. And what our customers find and have found is that they can meet the challenges of EDI with a virtualized infrastructure such as Xsigo's. And database, by delivering more bandwidth to every server, by giving a faster server-to-server connection for that cluster interconnect, you can achieve fantastic performance at a lot less cost by virtue of reducing the complexity. And then all of this obviously ties into the cloud. Service flexibility, virtual private data centers, increasing virtual machine density to meet cost requirements. All of these things are things that are enabled by the fabric. The fabric itself consists of really four elements. There's only one that's hardware that's unique to Xsigo. The card inside the server or card inside the blade is an off-the-shelf item available from anyone. The fabric director, the device in the middle of the fabric, is the Xsigo hardware device. It's managed by the Fabric Manager, a browser-based interface, or a CLI if you prefer. Another piece of software is called a Fabric Accelerator, and what that does is provide connections from server to server entirely over the fabric. So this is a connection which is not reliant on the Fabric Director itself, but in fact can go through the devices, the switching devices that make up the fabric. That connection, because it's not going through the Fabric Director, can actually go up to 56 gig per connection. So 40 gig for connections going through the Fabric Director, 56 gig for connections going server to server using the Fabric Accelerator software. And then finally the Fabric Performance Monitor, which lets you view historical data for anything within the fabric. So any virtual connection or physical port, you can view bandwidth over time, spot historical trends, see bottlenecks, when they occur, where they occur, and take steps to remedy them using the Fabric Performance Manager software. So these are the four elements that make up the fabric. The Fabric Director itself is comprised of two pieces. One is the server connections, which is on the top of the Fabric Director. And then below those are the I/O modules, and the I/O modules are the uplinks. So they provide you with the connectivity to your core networking, either 10 gig, 1 gig, or fiber channel. You simply plug in whatever I/O modules are needed for the uplinks you require in your data center. So part of the beauty of this is you plug in what you need today. Say you have a 1 gig environment and a fiber channel environment. if you want to add 10 gig Ethernet or maybe upgrade to 8 gig fiber channel, you simply slide in that I/O module to the Fabric director, and you now have that connection available to all attached servers. So very, very flexible and future-proof way to manage connectivity in your data center. The Fabric director is available in two sizes, the 780, which is the larger one on the left, and the 560, the smaller one on the right. They're identical with the exception that the 560 is 2U high and has space for 4 I/O modules on the bottom, whereas the 780 is 4U high and has space for up to 15 I/O modules. Other than that, the two devices are identical. It's also available with two different types of fabrics, 40 gig InfiniBand fabric and the 10 gig Ethernet fabric. Both offer the same functionality. Obviously the InfiniBand is the faster, but the 10 gig uses standard Ethernet NICs and a standard 10 gig Ethernet connection into the Fabric director. The I/O modules are available in 5 flavors right now: 1 gig Ethernet, 10 gig Ethernet, and then 4 and 8 gig fiber channel. And then as new technologies come along, new I/O modules get added to the family. So 40 gig Ethernet will become an I/O module that's available. 16 gig fiber channel will become a new I/O module. What this means is you can now buy those I/O modules in the future, plug them into your Fabric director, and that connectivity becomes accessible to all the attached servers without having to touch the servers themselves. You can connect up to 250 servers to a pair of Fabric directors, which means by plugging in 2 of these I/O modules, you've now saved